Oh, okay. Thank you. All right, I'll restart. Hey everyone, welcome to our Fullstack dapp developer workshop. Today we're going to write and deploy a smart contract on Polygon, and then I'll show you how to hook everything up to a front end so that you have a fully functional full-stack dapp that you use the front end to write and read from the blockchain, and then you can also see that on chain. Just to introduce myself, GM, I'm Steph. I'm a DevRel engineer at Polygon, and I'm also Oceans404 on Twitter. Feel free to connect with me and ask any questions there or in the chat throughout the presentation. I'm gonna minimize this. Awesome. Okay, so the main difference between a classic full stack Web2 app that you might be used to creating and a blockend or blockchain enabled Web3 dapp is that instead of having a backend either on the cloud or in the server, that is all on the blockchain. So your front end is pretty much the same as what you're used to creating, whether you're using React or any other framework, or maybe no framework at all. But instead of reading from a classic database, it's reading from the chain. And just as a refresher, I know you're all at ETHMiami, so you're probably hearing a ton about blockchain and Ethereum and all kinds of things, but blockchain is just a public database. Oh, oops. My screen switched. Sorry about that. A blockchain is just a public database that's updated and shared across lots of different computers in a network. So the block in blockchain refers to the data and state that's being stored, and then those blocks are connected within a chain because of cryptography that points at the parent. So children are looking at a parent, and if you change a parent, every single child behind it changes. So you know that we can cryptographically secure the blockchain to make sure that changes are really difficult to make and very visible to the entire community. So that's some of the power of having a blockchain as your backend or your data source rather than a obfuscated classic Web2 database. So we're going to be developing with Polygon proof of stake blockchain, or more specifically, the Polygon Mumbai testnet today. Polygon is an Ethereum scaling solution. We also have some really exciting stuff coming up in the next few months with ZK EVM, but today we'll be using proof of stake. Some of the really great benefits with developing on proof of stake are that transactions are faster than Ethereum, so up to 7,000 transactions per second versus Ethereum at 15 transactions per second. Very scalable. I think this number of 1.4 billion is actually wrong now. I think we're beyond 2 billion transactions recorded, which is awesome. Flexible, so it's fully EVM compatible. So anything you are used to developing with, whether it's Hard Hat or Remix or any of the tools, Truffle, Infura, all of those work out of the box with Polygon. So you don't need to learn a new language. You can use Solidity, and you also don't need to change up your tool set. Everything you're used to developing with for Ethereum will work out of the box on Polygon. And then possibly my favorite thing is that the cost of a transaction is significantly lower. A typical transaction could be a fraction of a penny. And so you pass those savings on not only to your users, but also to smart contract developers, right? Because when we deploy these contracts, they cost less than if you were deploying them somewhere else. So I always tell people at a hackathon, hey, it might feel really good to actually deploy to mainnet, and it's only a few dollars to have your contract on the mainnet, and then it's in prod technically, which is pretty cool. So the affordability of POS is another great thing about developing with them. Okay, so I assume a lot of you already have a wallet set up on your laptop or your computer, but just in case you don't, here are some steps really quick. So you'll download MetaMask, which is just a browser extension wallet that sits up inside of like the upper top right of your Chrome or Brave browser. Then create a new address or an account within MetaMask. I always like to create new test accounts when I'm doing test development, just so that nothing weird happens and I don't accidentally leak the private keys to one of my real crypto wallets. So after you have a new account, you can fund that account with Polygon Mumbai tokens from, oh, sorry, actually I skipped a step. So then you'll add the Polygon Mumbai network, which is a test network. By default, I believe MetaMask gives you Polygon, Ethereum, and a couple others. but you'll want to add the Polygon Mumbai testnet. And then the last thing to do is just use the faucet to add some testmatic tokens to your new test account. So once you have all of that, I'll show you away from the presentation. You'll have something like this. I have my little MetaMask browser extension up here. If I click into it, I'm just gonna put in my password really quick. I'm always super paranoid when I put in a password, like, is everyone gonna see it? Am I gonna leak it? But no. Okay, so I created a test account. It's called Guestbook. This is the address. I already funded it with some testnet-matic, and you can see that I'm on the Mumbai network. So I have the Ethereum
Steph, sorry for interrupting. Can you please share your screen?
Oh yeah, of course. Did it stop sharing? Sorry about that. Let's see. I'm gonna try to stop sharing and then I'll reshare. It says that I'm sharing my desktop. Can you see my screen now?
Yes, thank you.
Okay, I'm so sorry about that. I could see my screen. So I was just going through wallet setup and showing the finished result. So now I have this MetaMask Chrome extension. I created an account called Guestbook. I loaded it up with some testnet-matic. You can see I have 0.19. I think it starts at 0.2, and then I've slowly drained it with contract interaction. And the most important thing is that I'm on the Mumbai testnet. So I have a bunch of different networks up here. I have Ethereum, Eagle, Lychee, which is the ZK EVM testnet, Polygon mainnet, and some others. But I'm on Polygon Mumbai because that's the correct testnet for what we're going to be working on today. All right, so we've got wallet set up, or I do at least. The next thing is just a fun Vitalik slide, fiddle with me. So today I'm going to build something using React as my front-end framework, RainbowKit for some of the wallet connections. WAGMI and Ethers are dependencies of RainbowKit, which you'll see. I'm going to connect to the blockchain with an Alchemy API key. And then I'll do the smart contract development in Remix, which is an IDE, using Solidity, and then eventually we'll deploy that smart contract on the Polygon Mumbai test network. So I'll go back to presentation mode. Okay, so this is the dapp that we're going to build out. It's called Guestbook. And I actually, last time I was in Florida was for a wedding a few weeks ago. And I was thinking to myself, I wish that they had a guest book on chain because that would be so fun to go back and look at everyone who attended this wedding. So obviously this one isn't pretty enough to have at a wedding, but you get the general picture. You can see there's wallet connection up here. We're connected to Polygon Mumbai. This is way more matic than I have currently, but that was a different account. And you can see that this is a classic front-end form. So there's a name field, a message field, and a submit button. So you can kind of guess that the name of this last person was Steph, which is me. My message was hi, and the date that it was submitted was whatever this date is. I can't read. I guess it's 7 p.m. potentially in Colombia. So if I submitted a new one, it would probably be whatever I added plus whatever I submitted. And if you think in data structures, like a lot of developers do, you can imagine that this data structure looks something like this. So it has a guest info structure or object, and there are 3 fields that are represented here. The first one is a string, which is name. The second one is also a string, which is message. And the third one is a uint, or an unsigned integer, which is the date that it was posted. And we can use these objects to create a mapping of guest info, and we'll call that guest. So just imagine that all of this data is a big array or mapping of guest objects or guest info. So you can see the type is guest info, and we're mapping that as this big list of guests. I also will be tracking guest count in the contract, and that's just kind of for ease of use on the front end eventually, because I'm doing kind of some hacky stuff to map through all of these objects. But in a production app or something like that, you could do this in a much nicer way also. All right, so let's get into the code. You can scan this QR code to be taken to the repo, or you can just look it up. It's Oceans 404/guestbook. So I will click into that and we'll take a look at the code. If you want to totally ignore me for the rest of this presentation and just play with that code, that's totally fine. I updated the README about 17 minutes ago. I just updated some dependencies and added some prereqs, but the live link for this guest book is public. It's this right here, so you can click into it from the app. And you can see the first thing we have to do is connect wallet. So I'm just going to connect to MetaMask. I'll connect with this old account. Why is it connecting to accounts? Okay, so I'll just connect to one account. It's connecting. There's a little bug with RainbowKit right now that I actually have documented. It's a known issue where this modal stays pending even once the wallet's connected. So RainbowKit hopefully will be fixing that this month. But for now, just refresh the app after you connect your wallet if you're connecting with MetaMask. And then after you refresh, you'll see that state change, and you'll see that we've successfully connected this wallet to the guestbook. So now I can interact with this front-end dapp. I'll leave another message. I'll say, Seth, and welcome to Miami, because that song has been stuck in my head ever since I was thinking about ETHMiami this week. So you'll notice when I click submit, this MetaMask notification pops open. I'm just going to move this little pop-up. So this MetaMask notification pops open because in order to post this new object, I need to pay some gas. And that's because when I post this, there's going to be a state change in the overall contract or that list of guests. So I'm paying to update the state across the blockchain. As you can see, the gas fee is super minimal. It's like 0.000247 Matic, which is less than a penny, which I love. I'm just going to confirm this transaction, and you can see that something is happening. We're updating the data. And then once that's done, we should see it posted on the front end, but we should also be able to see it on chain. So I'll show you that next. And really quickly, I see one chat. Someone said, sorry, I'm late. No worries, Matt or Matthew. Sorry, I assume that all Matthews are Matt in my head. Okay, so we have this new message. It says, welcome to Miami. The person is Steph, which is me. And just for kind of like ease of use, I have a link to the smart contract. So I'm just going to click into this view smart contract on Polyscan. And on Polyscan, you can see all of the different places that there was a transaction, or all of the different times there was a transaction. It's also logged on Polyscan. So you can see that the last one happened 42 seconds ago. It was from this account AD65. And if you remember, that was actually my account that I logged in with my React app. So same. And then we can also look into this transaction by clicking into it. You can see it was from me. This is the contract address. You can see the gas price, transaction type, and you can see some input data. So this is where you can see all of the different things that were added. So remember, we had that data structure that had string name, string message, and then date. You can decode this input data, and you can see all of the information that was just added. So this is all stored on the blockchain and viewable either from our UI, from Polygon scan, or from the smart contract, which is pretty nice. So it's just an example of how it's viewable on any UI, it's public. And if you noticed, when I decoded that input data, I didn't have to pay gas or anything. And that's because reading is free. The only thing you have to pay gas for is writing to the chain. Okay, that was kind of just an intro to this guestbook React app. And again, the contract is viewable on Polygon Scan Mumbai, which is this link right here. We already walked through these 3 prereqs right before we looked at everything. It's just to create the account and then add those tokens from the faucet. But the next thing we're going to look at is Remix for the smart contracts. So I'm just going to open this link, which is a link to the Remix workspace. Again, Remix is a really nice Ethereum IDE, and it's, again, compatible with any EVM compatible project. So ours will work. I stored this as a gist, so it's also uploaded to my GitHub. Why is this so large? Okay, yeah. So this name is not very telling, but you can click into contracts, and I have 3 contracts loaded up for all of you. The first one is guestbook.sol. This is just the starter guestbook code. You can see on line 1, we have the license identifier. This is not required, but if you remove it and you try to save, the compiler will complain. So you always want to make sure that you have a license, because our code on the blockchain is immutable. So it's important that you always are able to tell people how they can use your code. So this one is GPL 3.0 license. I'm not sure what the specs of that are, but feel free to use it however you want. I see a few little questions quick. Oh, yep, it is kind of weird. But yeah, the compiler can read this comment and understand, okay, this is the license identifier. The next thing is the pragma on line 3. This is really important because it tells the compiler what versions of Solidity that you can use this code with. So right now we're saying it needs to be greater than 0.7.0 and less than 0.9.0. So the compiler will just understand that. If you go to the compile tab, you can actually see the compiler right now is using 0.8.7. So we all know math and numbers, I'm sure. So obviously that commit is between these 2 versions. So this will be able to run on the compiler. And then the last thing that you need to do when you're creating a smart contract is make sure that you use the contract keyword. This is just kind of declaring that this is the name of the contract. Ours will be guestbook, and the convention is to have a capital letter to start the name of the contract. So this is a completely blank contract. And I just went through that to show you kind of like what every contract has. The next one is number 2, which is guestbook starter. So this doesn't have all of the features that we'll add to our guestbook. Instead of storing a list of objects or a mapping, we just have an array of strings. And this is okay because the strings are going to be all the same type. And all we're doing in this guestbook starter is retrieving a list of names. So my name, your name, whoever else's name, but there's no messages yet. So it's almost like if everyone was just giving a little signature in the book. So this contract, same stuff up here. We've got the license, the pragma, the name. This name is a little different. But on line 10, the first new thing that we have is a piece of state. So this is a global state object called guest. And it's, again, an array of strings. And then we're going to have 2 different functions for this to read and get things for our guest book. So the first one is sign book, and the second one is get name. So sign book takes in a guest name, and then it pushes it to that array of guests. I like this because it's very similar to JavaScript. I don't know about all of you, but I come from like a classic Web 2 JavaScript TypeScript developer background. So anytime I see something I'm familiar with, I'm just like, yes, I immediately understand this. So this is the first function, sign book. It could be interacted with from a front end or anything like that. But I'll show you how to interact with that from Remix. The second one is get names, and this is just a public view. So it's returning all of the names that have been logged. I see a couple of questions. Oh, thank you. Are there optionals in Solidity? I'm going to Google that because I think I know the answer, but I never quite know. They're optionals. Yes, there sure are. Yes. So optional return statement. Okay, cool. Sweet. So next, I'm going to show you how to deploy this starter code. So the first thing you have to do is compile it. So you can compile by doing a Command S if you're on a Mac, or you can save it directly. If you noticed when I did the Command S, the Solidity compiler got a little green check mark. But if for some reason you just want to manually do it, you can also click this button in that third tab to compile the guestbook. And then after it's compiled successfully, you go to the fourth tab, which is deploy and run transactions. You can either use the Remix VM, which will just deploy it in Remix, or since we already have some testnet tokens in our account, you can switch to injected provider, which is MetaMask, and it'll use the funds in the account and also whatever network that you're connected to. In my case, I'm connected to Mumbai. And then you can deploy straight from here, which is super nice. So this will pop open because we need to pay some gas to publish this smart contract. I'm just going to click confirm because I'm not worried about my fake internet money, which is the Mumbai testnet tokens. And you can see a check mark. So this has been deployed to the blockchain. And we even have a transaction hash. So I'm going to go back to Polygon scan and check out this hash just to show you. This is the transaction hash from Remix. Oh, I see. So I just went straight to Polygon scan, but I actually need to go to Mumbai.Polygon scan because this is a blockchain explorer for the testnet, and I was on the mainnet. Okay, so now we can see this is a real transaction hash, and something happened. So this is my ETH address, and a transaction went through, and a contract was created, and we see this new contract at this address. So all that has happened so far is the contract creation, but let's publish a few names to that contract. So I'm going to go back to the Remix IDE, and now I'm in the deploy tab again, and you can go all the way down and you see the deployed contract. So this is the first deployed contract that we have, and I can sign the book. So I'm going to sign it with my name. And this is really nice because it creates like a tiny UI within the IDE where you can actually interact with the contract without creating a front end. So the lazy backend developer in me loves this. Cool. So it looks like this transaction was successful. I'm going to sign my book a few more times. I'm going to sign it by Teddy, who's my dog. And I'll also sign mom because I love my mom. And we can go back to that contract. And you see that two other transactions happen. I'm assuming this is me signing, Teddy signing, and my mom's has not come through, but if I refresh, I'm guessing I'll have another one in just a moment. Yeah, that just went through. Yep, so that was that third transaction. So let's look at Teddy's. We'll decode the input data. And you can see guest name, Teddy is a string. So that's all working as expected. And that's how you quickly deploy that contract. If you remember from our UI, the guestbook that we actually want to deploy is going to be a tiny bit more complex. And so if you want to go to guestbook complex, which is that third contract in here, I think this is a leftover. I was doing this in Hardhat, which is another Ethereum tool. You can delete that line 5 because we're not actually importing Hardhat for this one. But we looked at this code just a little bit before. This is the guest info object. It has the string name, string message, and uint state. We're creating a mapping of guests with this type, guest info. And also the mapping is created with the guest count. So I want it to be like 0th guest, Teddy, 1 guest, me, 2 guests, my mom. I think I misordered those, but you get what I'm saying. So that when I'm iterating through them on the front end, I can just loop more easily. So similar to the other contract, we have add guest, and then this one is a little different. This is get guest by ID. We can't do the same reading of every record because Solidity forces us to index them somehow or get guest by ID if we're going through a mapping. So that is why I added that uint to track the number of the guest. So this add guest function is very similar to the one that we just looked at, except for we have a couple more like inputs to this function so that we have all of the pieces that we need. And it's also a public function because we need to be able to call it. So in this case, the ID is the guest count, which starts at 0. We're creating a new guest with the ID of whatever we just created. So 0 is the first one, and then setting all of the different properties, name, message, and date to the inputs. And then after that, we're just iterating guest count in the overall state up 1 so that the next guest that we add has the correct count as they're mapping. And then the other thing we're doing is getting guest by ID. That's just so that if we wanted to return guest 1, it would return the correct one from that big list. So this is that more complex contract. I'm just going to compile it. You can see it compiled successfully. And then I'll deploy it with the same process that I just did. Okay, yeah, this is the correct one. I'm just going to click deploy. Again, we'll have to pay gas to deploy the smart contract. And once it's deployed, we'll interact with it just a little bit over here on the side. So I'm going to close that starter because we don't need that one anymore. And I'll actually delete it so I don't get confused. I'll pop open the little toggle for the complex book and add guest. You'll see that there's like 3 different fields. You can concatenate these if you want to. I don't really like doing that. So I like to toggle open this caret so that I can just add name, message, and date more easily. So I'm going to add Steph, which is me, GM, date. I'm just going to put 0, or this is just a integer, so it can be anything. I just typed in a random number. And I'll transact. I'll do that 3 times, and then I'll just show you. Teddy says woof, and his number will just be 50 so that it'll be incremented. And then I'll add 1 for my mom. Awesome. Okay, so now we have those 3 transactions. If you'll notice, the guest count has a public keyword. So because of that, there's an automatic getter added within the contract. You can see here, we can call guest count, and we should see the guest count. I think it will be 3, but let's see. Yep, so we can see that the guest count is 3, and we can also get guests by ID. So if I call it with nothing, I think it will fail. Yep, invalid argument. So I have to call it with ID. And if you remember, we're mapping those IDs. So I was 0, Teddy was 1, and my mom was 2. So let's get the Teddy object. So get guest by ID 1. Is returning this tuple, which is Teddy, woof, and that number that we assigned to his date. So now we have pretty much everything we need to start wiring this up to a real front end so that people other than me can interact with this contract and add data. And we're going to wire it up very similar to what we saw in the guest book. But the first thing I need to know is the contract address of this. So I'm just gonna look for it here. Oh, okay. So you can actually copy it straight from here. So I'm just gonna copy this and I'll put it in Polygon Scan so that I have it for when I need it. So this is the contract. We added 3 guests and it was created just 3 minutes ago. And I see a few chats. Yes. You definitely can call functions outside of the contract. Cool. Okay, so I'm just going to go back to this workshop for just a minute so I can present some things about the front end. Great. So the first thing we're going to do for our front end is set up RainbowKit. And RainbowKit is awesome because it makes connecting your wallet much easier than if you were going to do it from scratch. I remember doing it the old way and you just had to, there's so much code. And this is just a super nice library that adds some buttons so that you can connect automatically. You saw that in the demo. So the first thing you do is install your dependencies. I had to manually install because I was using React, but there's a really nice command if you're using Next.js or Svelte that you can find in the RainbowKit setup docs. The dependencies for RainbowKit are the RainbowKit or RainbowMe, RainbowKit library, and then also WAGME and Ethers. WAGME is just a React hooks library, and Ethers lets you connect to Ethereum and interact with the blockchain more easily. Then after you have installed everything, you can import these things. So you'll input the styling so that button looks really cute. You'll also import the get default wallets and RainbowKit provider. And then you'll import these things from WAGME. Those will just let you hook into your client and everything. So our client is Polygon Mumbai. The next thing you'll do is configure chains to connect to the Polygon Mumbai testnet. It looks like this. So you can see on this line right here, I've configured Polygon Mumbai and Polygon so that if you wanted to go from the testnet to the mainnet, you could do that once you're ready. The other thing is that we'll be using Alchemy to connect to an RPC node. So we'll have a process.env variable. It has to start with React underscore. So this is actually not correct, but I'll show you in my code. And then you're just setting that as the API key, which is your super secret key to your Alchemy connection. And then you also need these 2 little snippets of code. They're just telling you to auto connect if your wallet is already connected and inputting the connectors of the provider for the client. After that, you wrap the app. So you'll wrap it in these 2 providers. WAGME config is on the outside, and then the RainbowKit provider is on the inside. And then your React app just goes right in here, similar to how you would do this if you were doing some kind of like routing in a React app or anything like that. Next, we're going to use the connect button. So you sign in with the connect button. That was that button up in the top right that I connected to at the beginning of the demo. This is a component that's provided by RainbowKit, which is, again, really nice. All you have to do is import the button from the library. And then within your app, you can just add this button and then it works out of the box. It doesn't always, as we saw at the beginning of the demo, there's 2 little bugs with it right now. If you are connecting, you have to refresh the page. There's like infinite load issue. And also if you're disconnecting, you also have to refresh the page. But I'm sure the devs will get on that. Or maybe one of you will if you wanted to create an open source pull request. This would be a really great issue to tackle because tons of different dapps and community applications, I'm sure, are kind of annoyed about this button having a couple little bugs. Okay, so let's get back into that code for the front end. Scan that if you'd like to go back to the code. So for the front end prereqs, you have to have Node installed in NVM. I'm using NVM version 16 or a Node version 16, which you can set by running this command, nvm u16. The next thing you need is an Alchemy account. I already have one, but I'll show you that process. So Alchemy has tons of cool APIs. It's an incredible Web3 development platform. It has like a super node and just a bunch of cool things. Yeah, here's the super node with this fun design diagram. And then it has NFT, APIs, DeFi things, wallet things, all kinds of things that make your Web3 development a lot faster. So highly recommended this if you're developing any of these types of dApps. But this is what my dashboard looks like now that I'm already signed in. I think the free tier lets you have up to 5 dApps. So for now, I'll just, well, I don't want to delete any of these in case I need them, but you would create an app here. You can name it anything you want, describe it as anything you want. The chain is Polygon and the network is not the mainnet, but Mumbai. When you create the app, it'll show up in this list, and then you can just view the key. So this is the key that I was using today. You'll copy the API key because we'll need this for the front end. Okay, so if you want to, you can clone and star this repo and CD into the guest book. I'll just do it from my terminal. And you only have to do 3 things if you wanted to just get this up and running and to not connect it to your own. You would npmi, which would just install all those dependencies in the package JSON. Most of them are probably things that you're used to. Emotion is just like a styling library, I think. Or no, I want to say it's icons. Font source is just like the Google font for Roboto. Material UI is what I was using to create some of the buttons and components for the front end. And then Rainbow Kit, Ethers, and WAGMI are necessary for that connect wallet button. So all of those should be installed with the npmi command. And then the other thing you'll do is you'll run this command to copy the .env.sample to a .env file. So I already did that. This was the sample. You can see that your Alchemy API key is empty, or it has like a non-API key value. So what you'll have to do is in the .env file, replace it with whatever your Alchemy key is. So mine is this one. I'm just going to copy it and paste it here and save my .env file. After that, you can update the app.js file with the contract address. This is just a variable within app.js. So go into the source folder, go to app.js and contract. Okay, so this was my original contract address, but I want to read it from the new contract that we just deployed together. So I'm going to copy that from here. And I'll just replace this and save. And going back to my nice little README. So all we have to do now is npm start this dApp. And if all goes well, we should be able to connect to that new one. Awesome. So my wallet was already connected. And you can see that this is that contract from Polygon Scan. It has those 3 messages that we just posted during the demo. And this should be that same contract. Yep. You can see the transaction ages are 9 minutes ago, 10 minutes ago, and 11 minutes ago, just to prove that I didn't set all of this up and rug y'all with the demo. But yeah, so you can play with this to create your own full stack dApp. And then just to show you a couple other things that are important about this, when we're posting that data, let's see, so in the front end, where did it go? These are just classic inputs that you're used to. And then the submit button. This is very similar to what you would see in a normal React app, handle submit. So I'm just preventing default and then running this function, which is add new guest. Let's just look at that. So this is taking in the guest number, returning if there's no guest count. So if there's nothing in the form. If type of window.ethereum is not undefined. So this if statement is just checking that there is a window.ethereum instance, and that is present if there's a MetaMask browser extension or other wallet extension, so that it's injecting in Ethereum. The provider is using Ethers, which is that library that connects to the Ethereum blockchain, and then passing in window.ethereum. We have a signer. We also have the smart contract. So it's reading the contract address and also the ABI, which I'm realizing I completely forgot to talk about. The ABI looks like this, and I've already added it inside of the contracts folder, but you can also get it from Remix. But what it is basically a list of all of the data types that this contract has so that your front end understands how to talk to it. So these are the different components of that guest type. So we have string name, string message, and uint date. The guest info was a tuple, remember, because we had those 3 different fields being posted. This is an event that I actually removed from the contract, so ignore that part. But you can also see there's the function get guest by ID, and there was one other function, add guest. Yeah, there's also the function add guest. So it's just referencing all of that. And you don't need to create this file yourself. It's available in Remix after you create a contract. So I'm just going to go back to Remix and show you the ABI. I can't remember if it's in the compile tab. Oh, here it is. Okay. So in the compile tab for the smart contract, at the very bottom of that tab, you'll see an ABI copy button. So you can copy this ABI to the clipboard, and I'll just create a new file so you can see it. And it gives you all of these inputs for the add guest function, the inputs for the get guest by ID function, and guest count. So I'll just replace that really quick because this is the correct ABI. Okay, so back here, the contract is just connecting to the contract address, the ABI, and the signer. If you noticed in the front end, I didn't actually have a field for date because I thought it would be annoying for people to add their own date, and we can just do that with JavaScript. So on the fly, it just grabs the current date and converts it to an integer, so that's stored. And then this is how we interact with the contract. So contract.addGuest, we know that's a function because of the ABI. This also has that add guest, taking in these 3 inputs of name, message, and date. So back in the app, you can also see the inputs of the contract.addGuest function are current name, current message, and the date that we generated on the fly on line 119. And then we just have some React stuff. So set is updating to true. That's just controlling the loader that is a state variable in my React app. This is just an await function so that we're waiting for the transaction. And then after this happens, we can set is updating to false so that the form is able to submit new records. Then I'm just clearing out the 2 state variables for current name and current message so that the form also clears, and updating the guest count. And that's kind of everything that's happening on the front end of this dapp. So I'll just go back. So yeah, so to recap, name, message, submit. On submit, it does all of that logic so that we post the new message to the smart contract. And then we read all of the new messages one more time. And this is actually an old, oh, I see what's going on. This is the production version, so it's still connected to the old smart contract, but the localhost version on 3000 is connected to the new smart contract. And as a last step, I'm going to add one more name, message, and submit to show you that we can also submit from this front end, and it'll still post to the address. So Miami is awesome. I'll submit this. Beautiful gas fee. So low. You can see the updating. This was that loading state that I just showed you in the code. And hopefully we'll see that message posted here in just a sec. Oh, looks like I have a little React bug. It just reposted all of them. Okay, so I'll have to look into that, the deduping front end issue. But it looks like everything's all good here, and we did have a transaction post 26 seconds ago. And last thing, just to super prove that we can read this from any source, I'm going to go back to Remix and I'll read guest 1, 2, 3, 4, or I guess the index would be 3 of that guest. So back here, we transacted on a different front end, but we should be able to read that third guest, which is Miami. Yep, Miami is awesome. And this is the date. Amazing. Okay, let me just make sure there's nothing else to wrap up in the code. We went through setup instructions, those 2 known issues with Rainbow Kit, which was the connect wallet button modal pending, and the disconnect feature was also broken. But the other thing is, if you want to deploy to Vercel, you can totally do that. One other thing that I forgot to add to this repo is that there's this really cool front-end deployment tool called Fleek. And it's awesome because it's a decentralized deployment. I think I have it documented in one of my other GitHub repos. I'll just show you that really fast. Yeah, so if you wanted to host your front end on IPFS, which is like a decentralized place to host websites and other files, you can use Fleek, and I have some instructions here. So I'll just paste this link, copy link, see if that works. Yeah, so I'll paste it in here. This is for Fleek deployment, and yeah, let me share the GitHub URL for the actual guest book as well. Awesome. So you can deploy your own guest book, and again, feel free to modify any of this code, use it however you want. Happy to have that be open source. So yes, we are. Oh, last thing, if you want to verify your contracts, you can do that on mumbai.polyscan.com. That just makes it so that you can read all of those decoded inputs on Polygon scan. So I recommend that because it helps everybody understand what's going on if they just wanted to look at your smart contract, but didn't have a front end or any context. Here are some other developer resources if you want to look into anything else about Polygon. We have a dev library on Notion. We also have our general documentation. We have Polygon University, which has some cool new courses, including one on Polygon ID, self-sovereign identity. Our education team is awesome, so check that out. And then the last thing is just ethereum.org, which sounds basic, but I love going back and reading some of those docs, especially after being a dev for a bit. It's nice to reread those docs and understand, like, oh, wow, I get what they meant by this concept now. So just kind of a fun thing to check out if you have some time to this weekend. Also, tweet at us, OX Polygon. We also have the handle OX Polygon Devs if you have a project you want to share. We love retweeting all of your tutorials and demos and everything. So let us know what you're building. And thank you so much. We're all going to make it. This is the slides and GitHub repo QR code, so feel free to scan that if you want to have the slides forever and always. But yeah, thank you so much. I'm going to stop sharing my screen and I can take any questions, comments, concerns.
Okay, thanks a lot, Steph. Do you have any questions here? Yeah, we have one question. 1 second.
Yeah, of course.
Here we go.
Hi, I wanted to, well, thank you for the lesson. It was really cool. I wanted to ask, where did you get the React code for the app? Was it the Alchemy key, or did you already have that pre-made, all of the whole React app?
Yeah, so I pre-made the React app. I'm not fast enough at coding in React to do it on the fly. I tried that once and I just didn't finish. So I did that ahead of time, but you can check out all of that React code in the repo. But the Alchemy
Right.
key part was just straight from the Alchemy dashboard URL.
Any more questions? All right, Steph, thanks a lot for your presentation. The video will be saved and posted, and whoever missed, they will have a chance to review that again. Yeah, one
Awesome.
more, 1 second.
Do you mind explaining the mapping section in the smart contract again? What is the mapping? Why do we use it? Why is it important? What exactly is it doing?
Yeah, totally. Let me drop a link to that section. Actually, do you all have access to the GitHub repo? A mapping is, I don't know if I'm sharing my screen, but a mapping is just very similar to an object in JavaScript. So it has a key value pair. So in this case, we had the key as just an integer. So it started at 0 and it went all the way up to however many guests that we had. And it was just so that I could do like an iteration on the front end to pull all of those records because I wasn't storing an easier way to get the whole list. Remember in the there were two different smart contracts that we looked at. The second one was just an array of strings. So you can pull that whole array back and read it from a smart contract. But if you're doing a mapping, you can't reference like the whole list. You can't say, give me all the guests in this mapping. You have to reference them by a specific key. And that's why we had to do it that way, because we couldn't get all of them at the same time with all those fields, just because it would be an expensive read and a scaling issue down the line. If we had thousands and thousands of guests, we wouldn't want to return thousands of records. It would just be like bad practice, and Solidity prevents us from doing that. So we had to use a mapping with those key value pairs. Sorry, that's my dog, Steady.
All right. Thanks a lot, Steph, for the time you took to explain us everything. And again, it's going to be posted online. So whoever missed will, it will be available probably tomorrow.
Awesome. Thank you.